So this video is about kinematics, which is particles moving in a straight line. And there's 5 quantities that you need to consider. And these are S, U, V, A and T. S is the displacement. Displacement is a better word than distance, although sometimes they mean the same thing. U is the initial velocity. V is the final velocity. A is the acceleration, which in this unit is always constant, it doesn't change. Sometimes it's 0, and T is time. What is acceleration? Well, acceleration is the way in which the velocity changes over time. So it's the difference between a final velocity and a starting velocity, and it's per unit per second. So from that we can rearrange that. We get V minus U equals AT. So that's sometimes written as V, or it's normally written as V equals U plus AT. What is the distance travelled? The distance travelled, which is S, is the average speed multiplied by the time. Now from those 2 equations we can generate all 5 SUVAT equations. SUVAT, just to remind you, is displacement, velocity, acceleration, time. So if we take the first equation here and make T the subject, T equals V minus U over A. Let's substitute that into 2. So S equals U plus V over 2 multiplied by V minus U over A. So U times V, that's UV, minus V times U, that's minus VU, they cancel out. That's V squared, that's minus U squared, and we've got 2A. So these terms are equal. So we've got multiply both sides by 2A, so we get 2AS equals V squared minus U squared, and that's normally written V squared equals U squared plus 2AS. Now from equation 1 we can see that V equals U plus AT, so let's put that into equation 2. S equals U plus V, but V is U plus AT, over 2 times T. Multiply both sides by 2, so we get 2S, U plus U is 2U, that's all times by T. So 2S equals 2UT plus AT squared. Divide everything by 2, we get S equals 2U2 over 2, that's just UT, plus 1/2 AT squared. And that's our 4th equation. Now let's take equation 1 and say that U equals V minus AT. And let's put that into equation 4. So S equals V minus AT times T plus 1/2 AT squared. So let's multiply it out. So S equals VT minus AT squared plus 1/2 AT squared minus a whole AT squared plus 1/2 AT squared is minus 1/2 AT squared. So S equals VT minus 1/2 AT squared, and that's our 5th equation. So these are the 5 SUVAT equations which you do need to remember. Notice this equation here doesn't have an S in it, this doesn't have A in it, this doesn't have T in it, this doesn't have V in it, and this doesn't have U in it. So when you get a question you need to determine which of the variables you're not particularly interested in and choose one of these equations to use. You just need to remember these equations. So here's an example of how to use SUVAT. We've got a car with constant acceleration. At one lamppost its speed is 20 meters per second, and the next one it's 25 meters per second. How far apart are the lampposts? So with all these, write down SUVAT and see what information you know. The constant acceleration is 0.6. The initial velocity is 20. The final velocity is 25. And it's the distance that you want. So we're not really interested in time. So the equation that doesn't have time in it is v squared equals u squared plus 2as. So we can use that. So 25 squared is 20 squared plus 2 times 0.6 times s. So 25 squared is 625, 20 squared is 400, 2 times 0.6 is 1.2, so therefore 225 equals 1.2s, so s is 225 over 1.2, which equals 187.5 metres.